All right, let's get started. Hello, everyone. Welcome to the American Aerospace Webinar for InstiMaps, which will be led by David Yoel, CEO and founder of American Aerospace Technologies, Inc. My name is Rachel Johnson, Geospatial/Project Control Specialist here at AATI. Just a brief overview. David will present a brief overview of InstiMaps, followed by a web map demonstration of our Hurricane Irma response campaign flown this month on September 14th and 15th. After that, we will have time for any questions that you may have. Just a quick note, we have muted all attendees during this presentation. If you have any questions while David is talking, please use the chat function of GoToMeeting. I will be tracking questions and we will answer them at the end. We will also have time to open up questions to the floor for anyone who may have them then. Now I will turn it over to David.
Good afternoon, everyone. Thank you for joining us today. My name is Dave Yoel. I'm founder and CEO of American Aerospace. We will briefly review InstiMaps capabilities, jump into the web review as Rachel indicated, and we'll talk about applications and then go to questions and answers. So very briefly, we received a great response to the invitation today, and we're really excited to be presenting to the group. We have representatives from oil and gas, telecom, other infrastructure companies, as well as public agencies and first responder organizations from across the country. AATI is a sensing as a service company focused on rapid delivery of critical geo-corrected remote sensing data. We have expertise in remote sensing and geospatial computing, as well as aviation. We've integrated sensors onto a wide variety of different manned aircraft. We're UAS airspace experts, and we're beyond line of sight, beyond visual line of sight, unmanned aircraft system experts, having flown in the national airspace since 2010 across the country. We've served companies in oil and gas, utilities, telecom, academia, and government agencies as well. So InstiMaps data services with manned and unmanned aircraft is our primary focus today, with cloud-based geospatial data dissemination services. We also offer special projects and UAS systems and concepts of operations development. And in addition, we produce products such as unmanned aircraft systems and mobile operations centers. So InstiMaps is a cloud-connected imaging system that delivers high-resolution, geolocated, multispectral imagery, both visible and calibrated long-wave infrared. I'll point out that we use framing cameras. This is not video, and that means it's a sequence of snapshots that are rapidly put on a map that allows us to deliver with the same kind of bandwidth, much higher resolution imagery in near real time. So this is not a tool one would use for tracking vehicles or those kinds of applications, but that it's one that gives you great situational awareness and great resolution very, very rapidly. It's nadir or downward-looking imagery. We have a range of other sensors and applications that we support, sometimes simultaneously. And in the image down here at the bottom, we're showing our geospatial lead, Gabe, at an emergency response center receiving imagery from an InstiMaps payload minutes after it was collected 15 miles away, straight from the aircraft to the cloud and across the disaster response exercise. In this case, it was the hurricane response exercise in Cape May, New Jersey in June of 2017. Wanted to give you a sense of the resolution and coverage rates. I certainly won't read all the numbers here, But just to give you a sense, with a typical 28 millimeter lens at a 2,000-foot resolution altitude, we're collecting a half-mile wide swath of imagery at 4-inch resolution at 75 miles an hour on UAS. And when we do area collects, there's a lot of factors to go into it, but roughly speaking, we're collecting at about 37 square miles an hour for 10 hours per mission, up to 10 hours per mission. On manned aircraft, our typical linear coverage rates are up to 127 miles an hour at a half mile wide at 4-inch resolution. And we can collect area maps at roughly 62 square miles an hour. Typical manned aircraft endurance is 4 hours versus the 10+ hours for UAS. So you can get a sense of the areas per day that we can cover with the different kinds of platforms. We have complementary long-wave infrared imagery also being acquired and geolocated with similar footprints and coverage. In terms of communications, we operate in 2 different modes. One's near real-time data delivery. We can do that with our own dedicated radio networks, but we've also been experimenting with and developing airborne LTE with Verizon Airborne LTE Operations, ALO technology. We're in large-scale trials now with that, and as an example, during a pipeline emergency last year, over a 200-mile linear collect, we were able to stream imagery in near real time from the aircraft along a 200-mile corridor. I was in my office 1,500 miles away receiving the imagery within minutes of it being acquired direct from the aircraft. What we do is we transmit the real-time imagery. It's compressed, so it's lower resolution. I'll just jump back up to the resolution page here, and you can see the low-res, high-res resolution is different because we're compressing the real-time disseminated data. But then what we do is post-flight, we upload the full resolution imagery to the cloud and across the enterprise. So we have a rapid situational awareness and data management platform. We're talking about today, we call it a web map. It's a simple geospatial interface. It's very similar to the kinds of Google Map application you might have on your phone as you look at traffic and the like. It's very intuitive. It displays the geolocated, visible, and infrared imagery, but also data products we can produce post-flight, including mosaics, 3D point clouds, thresholded infrared imagery, and heat maps. It's mobile compatible. In the web map, you have archived layers of data from previous flights, so you can do comparisons very rapidly to detect change visually. And there's a measurement and analysis capability. You're able to make area and distance measurements, for example, and you can share threat markings across the enterprise, because this web map is shared across all authorized users. So beyond our own situational awareness platform, our web map, our data products are Open Geospatial Consortium compliant and have been tested to be plug and play with NOAA's Emergency Response Management application, ArcGIS, and IntelliSphere, among others. The InstiMaps sensor package is platform agnostic. It operates on both manned and unmanned aircraft, and we've actually even on the same day flown the same sensor on both manned and unmanned aircraft in an earlier test. Applications include emergency management, emergency response, including man-made and natural disasters, the range of applications in the oil and gas sector, from pipeline integrity management to oil spill patrol and response, and a whole range of extreme applications. Electric utility applications include electric transmission line patrols, the linear infrastructure patrols like railways, communications infrastructure, mapping coastlines and waterways, ports and harbors. Just to focus on disaster response applications, subject to today's discussion, applications include, disasters include hurricanes, tide surge events, tornadoes, ice storms, fires, heavy rains and floods, earthquakes, and I'm sure there are plenty more. So in the immediate aftermath of a storm, rapid damage assessment can be accomplished with a tool like InstiMaps to document casualties, the condition of emergency shelter, condition of roads, bridges, ramps, flooding effects, scouring at river crossings, changes in the banks, coastal erosion, critical infrastructure inspections from pipelines, power lines, communications, sewage and waterway systems and water systems, also waterways, ports, harbors, hospitals, and other critical infrastructure. I can assist with search and rescue, with security, with large animal recovery, providing a shared situational awareness platform for the emergency response exercise. Pre-event, mapping can be done to document conditions before the storm or event, but in addition, these pre-event image layers can help with rapid assessment of the change caused by the disaster. And then in the recovery phase, this photo documentation can improve reports, improve knowledge of the conditions caused by the events, help track construction and recovery, and in disease prevention, everything from mosquito abatement to a large animal recovery to prevent disease. So about the Florida Keys deployment, a company requested us to deploy to survey 38 specific pieces of critical infrastructure in the Keys. And it was a specific linear collect we performed to acquire imagery of those specific locations versus an area collect. And we'll talk a little bit more about that in a minute. We also acquired oblique imagery of specific infrastructure, but we're not able to show that to you today. I'll show you some other examples in a moment. So we deployed on a Cessna 206 from Philadelphia on September 13th. We staged out of the closest active airport that had fuel available. That was in Miami. We acquired imagery on September 14th and 15th, and then created and disseminated web maps on the 15th and 16th. So with that, let's jump into the web map. This is live now on the cloud, and the web map you can see here covers the full Florida Keys. We can zoom to any location. It has a number of different layers of base maps from street view to imagery. There's a topo layer as well as a max zoom layer, which allows you to zoom in to observe the imagery in great detail. There's a marker layer where you can open up your interest points, each of which has anyone that has access to the web map can mark locations. In a future version, we'll have various colors of these types of markers. We can open up a layer that shows the flight path on any given day, so you know the area of operation for any particular collect. And then we have the various image layers, which I'll activate now. We have both visible and infrared. You can see that these are marked by day and then by region. So let's start in Big Pine Key. This is an area where there were indications of tornadoes, and winds up to 170 miles an hour were at least reported, if not confirmed. Here you can see the street layer view with the highway running through. And again, we did an area collect rather than map the entire area because we did a linear collect instead of an area collect because that was our tasking. But I can zoom in here now and look at the conditions in the area in near real time. I'm going to go now to the max zoom layer so I can zoom all the way in and show you the resolution of the imagery. And at every point here on the image, we have the latitude and longitude. We can make measurements. Let me show you here this coastline area where you can see some very severe damage to this building. You can see that the dock was washed away and the building was largely destroyed. You can get this imagery again at 127 miles an hour at half-mile swath width at 4-inch resolution. Then we'll go to the area of excuse me. This is Sugarloaf Key. And this was an interesting observation that our friend Jim Eberwine, retired Weather Service hurricane and weather expert, pointed out to us. There we go. Where you can see side-by-side buildings, and it takes a minute for the full resolution to come in because of the size of the magnitude of the imagery. But you can see a destroyed home right next to a home that's basically in perfectly good shape, at least from the air. And you can, and this gave Jim and his colleagues an indication that a tornado may have struck at this location because of the variability of the effects. And then here you have a similar indication with a destroyed home next to a home that's in good shape. Next we'll go to Key West. Well, let's go here and see what we have. Yeah, this was interesting too, just to see in the post-disaster environment, we had a staging area for recovery equipment. This is a mosaic of the King of Prussia Mall with a transparency layer set up so you have before and after imagery. So you can see an example of the ability to detect change in the imagery from multiple flights. This is part of a mosaic image that is somewhat significant in extent. It's you can make measurements. For example, we've got 1,000 feet across this mosaic. You can do area measurements as well. You have the geographic coordinates of the area as well. This one's 9.31 acres or 2,360 square feet. You can save those and share those. You can place markers and annotate them for your team, and these go straight out to, you might be tasking in a post-disaster environment, for example. And as we zoom out in this web map, we can also integrate in still images of various kinds. This is our old shop with imagery of the hillside in the back, which slide. You can save these images to your desktop. Here we have a 3D point cloud of a sand pile that was created out of 2D imagery. This is a post-flight data product. You can make volumetric measurements, linear measurements as well within the 3D point clouds. And this particular web map spans about 100 square miles of area. And for example, down here in Cape May, we have an orthomosaic photo that's image that we produced that's 15 miles long. We also have a point cloud of the ferry terminal, for example. So this web mapping application can be used for displaying multiple collects and multiple types of data in a geospatial format. Okay, so we have a question from Justin Adams. Does your system require an STC from the FAA? It depends on the configuration of the aircraft. If there's a belly port, then it flies inside the aircraft and does not require an STC. In our pod-mounted configuration, the pod is STC for any standard Cessna 172 or 182, and is basically a plug-and-play installation. Another question, how much of the post-storm analysis was automated using algorithms versus using human in the loop? In certain markets, such as in pipeline integrity management, we have been developing and working with testing algorithms for automated machinery threat detection. We've done in-flight tests, and we have begun to develop a measure of false positive and false negative rates. We continue to work in the field. We're testing a whole range of algorithms now, and we continue to develop them. Some of the algorithms do work currently in terms of infrared thresholding. We're able to identify, for example, ships and shipping channels in the infrared. We've done some testing with algorithms for machinery threat detection using infrared imagery. It's effective for fire mapping, but there's a long road to developing algorithms that are fully autonomous with low false negative and low false positive rates. We're on the road and working actively in the field. Somebody asked to see the ferry terminal on our web map demo, so I can zoom that in here and display that. Here's a 3D point cloud of the ferry terminal. So in a coastal environment, you can get a very good sense of the condition of infrastructure is with an application like this. Let's see if I did have a question here from JC Coffee to see, has this been shared with state and local emergency management teams? So we have shared this with New Jersey and the local Coast Guard sector, New Jersey State Police, Coast Guard sector, Delaware Bay, Cape May County, as well as municipal first responders. We conducted an emergency management exercise in June, a hurricane response exercise. We flew a cell site to provide communications on a UAS in a post-disaster environment, and we also exercised the use of this tool for rapid dissemination of InstiMaps imagery across the enterprise. We were able to get the web maps to the Regional Incident Operations Center near Trenton, about 100 miles north, as well as to the County Emergency Operations Center 15 miles away, and to mobile devices on the web mapping application during the flight. Next question, how quickly can the capabilities be deployed in emergency situations? Currently, we can deploy within about 24 hours from our current location with the ability to put this on a range of aircraft, though we're working on a network of aircraft to be available so that we can simply FedEx the payload to the location of the disaster and be able to respond even more rapidly in the immediate aftermath of the storm. What's the smallest UAS that the sensor will fit on? The smallest aircraft we've integrated with so far is a 52-pound fixed-wing small UAS that fits under Part 107 operations. But generally, that particular aircraft is a long endurance system. We've also looked at integrating with small electric drones, and that seems quite viable. One point I'd like to make is that the imagery was available before the keys were opened back up, and was available to help assess damage in the days after the storm. As we move forward, we anticipate the ability to deploy immediately after the storm to provide that imagery literally within hours of deployment. Next question is there a price sheet for these services? Not quite yet, but if you're interested, we're more than happy to talk with you and work to provide rates if you're interested. Are we able to stream data real time? We've had success using airborne LTE operations from Verizon and streaming imagery over a 200-mile segment of pipeline corridor continuously, with imagery arriving on the web map within minutes. It's still in development, but it's an emerging capability that's in the pilot stage. Seems like you need a military-grade budget to run these apps. Actually, we've developed this with a commercial off-the-shelf technology mindset and in a commercial civil government mindset, and we found that we believe that that our rates are going to be much more akin to commercial rates than military rates. American Aerospace willing to bring their InstiMaps equipment to mount on a customer's aircraft, assuming the aircraft is compatible? Absolutely. We don't have a fleet of manned aircraft. We integrate our sensors with our customers' aircraft and with their aviation suppliers' aircraft to deliver the imagery in the mean with the aviation component that they're interested in. What are the alternatives to this technology, or was it previously unavailable? To our knowledge, a capability like this with rapid delivery of data hasn't been available outside of the military sphere, where connectivity is ubiquitous and is not, and the cost of which is not a significant consequence. So we think this a new capability, especially with the rapid dissemination ability across an enterprise. Do we coordinate with Fema and local emergency management for the Florida operation? We did
not. There were no TFRs in place. We did our best to reach out to FEMA and to local emergency management organizations, but we didn't have the mechanisms and experience with them that we do in the Mid-Atlantic, where we have pre-coordinated in the event that there are disasters. So one of the things I hope that we can achieve from this conversation is to have people suggest to us how we can reach out to be more able to communicate with first responders, and in particular to have them think in advance about how we can support their operation. Okay. Do we perform image processing, for example, to detect change on pipeline right-of-ways between runs? Yes, we do. We have the ability to do near real-time monitoring and marking, and to disseminate threats directly to customers through the web map or through an application like IntelliSphere. We're also working on the concept of operations of having the pilots able to mark locations where they've seen things in flight, and to have the images delivered to users across the enterprise in near real time correlated to those observations. In addition, we're working on the ability to do automatic detection, but we're also complementing that with human review to assure that we achieve low or no false positives and low false negatives and low false positives. Do you need FAA approval to fly UAS, and do we have it? Yes, we've operated under 10 airspace authorizations across the country, these long endurance UAS. We currently have access to about 17,000 square miles of airspace. In the aftermath of a disaster, there's a process in place in which we can request the operation of these long endurance UAS from the FAA to operate in specific TFRs established for the aircraft, but also to fly into TFRs that have been established over disaster sites, for example, as occurred in the Houston area after Hurricane Harvey. There is a mechanism in place, and we understand exactly how to implement it. Can I provide an estimate of data volume per flight segment? That's a great question. Off the top of my head, I'd be challenged to give you a good number, but I'll happy to get back to you with an answer. Imagery takes a lot of storage, and it takes a lot of bandwidth to transmit. And so one of the things we focused on with this capability is the ability to deliver data quickly. And one of the reasons we have this web mapping application is because we can provide that archiving and storage of reference image sets and of current imagery, so that our customers don't have to develop the servers and the storage systems to acquire and hold all this data. We can simply make it available to them on demand, and it's compatible with their existing applications, so that it's seamless and plug and play. Tell us more about your disaster response plans in the Mid-Atlantic. Well, we've conducted emergency hurricane response exercise in New Jersey. We've done that with both with a flying cell site to provide communications in a post-disaster environment, as well as InstiMaps to provide near real-time imagery and situational awareness to first responders. Hopefully, I'm not being redundant here, but we have prepared with an exercise involving Cape May County, municipal, local responders, New Jersey State Police, Coast Guard Sector, Delaware Bay, Verizon, of course, and we were able to disseminate imagery over across the emergency response enterprise very rapidly using airborne LTE. Have you developed UAS integration plans for those who do not have staff with these capabilities? Yes, we have. We're operating both under Part 107 and under the certificates of authorization at large scale. The large scale operations do take some time to establish. We've conducted several pipeline patrol exercises using long endurance UAS. We're on standby now in the mid-Atlantic to conduct hurricane response operations with UAS, and we're also working on an oil spill response project offshore in California. We're planning to conduct later this year with the mechanism in place to actually be able to deploy these tools in post-disaster environments. The persistence becomes a real key to these UAS because with 10 to 16-hour endurance, we can provide coverage for long periods of time at large scale. At, for example, 30 square miles an hour for 10 hours, you're talking about 400 square miles of patrol per day. And with higher altitudes, lower resolutions, those numbers can go up to 1,000 square miles a day of persistent surveillance. Some of us have limited staff. What do you do to support those kinds of companies? Well, and entities. Well, so we have a geospatial team here. We can produce geospatial data products on demand, including orthomosaics and 3D point clouds. We can do review of imagery and just forward imagery of interest because of its identifying a potential threat, say, for example, on a pipeline corridor, so that staff at the end user enterprise doesn't have to review all data. On the other hand, that data is available on the cloud so that people can go back and review data in from prior flights to do comparisons. They can pull up data when they need it. So we provide value-added services as well as the raw imagery on map. Question is, well, what is a TFR? That's a temporary flight restriction issued by the FAA, often in the aftermath of a disaster. And a TFR is a mechanism we will use to fly the long endurance UAS. We also understand the mechanism of flying within these temporary flight restrictions with manned aircraft after a disaster. And let me point out also that disasters include both man-made and natural disasters, including specifically critical infrastructure recovery. Talk about growth of data annually. Well, today, about 500 petabytes of aerial imagery is being collected for civilian applications every year. And our forecast is that by 2021, that's going to grow to 7,000 petabytes a year. So the ability to deliver data, and especially to large enterprise with large number of aircraft operating simultaneously in their areas of interest, becomes a real challenge, and that's one that we're addressing with InstiMaps and our web mapping applications and cloud-based tools. Do we have visual line of sight waivers for UAS activities on pipeline projects? Yes, we have in specific locations where we've conducted beyond visual line of sight UAS operations. We've flown to date about 20 miles down a pipeline corridor with UAS in a post-disaster setting. We believe we can extend that out to hundreds of miles. Here we go. All right, so here's, let me get my marker layers back on. Thanks to those of you that have stuck with us, much appreciated. These are new tools, and we're learning every day. Here's a marker, for example, just in the Key West, max winds were reported at 90 miles an hour. And as you zoom in here, you can see some of the damage that took place. Also, a little bit further down the Keys here, Key West, I should say, of interest to some of you on the call are some storage tanks. And again, you can mark the web map here. Let's use our measurement tool from, for example, the street view. Let's say this was a damaged piece of infrastructure. If you, in the street view, you've got a marker set here, you can make a measurement, for example, and say that, and put in your marker or report to somebody you're asking to respond that 305 feet south of Fleming Street on Thomas Street is a response location, and that you, here's the imagery of the site. This is what you need to do to prepare, and here's how you can get there. Another example I thought was interesting here in the imagery was this location where you can see a bunch of recovery vehicles already on site. This is imagery from the 15th, so it's already several days after the disaster. And you can very, very clearly see the equipment that's there, and you can see that different types of machinery. You know its exact location. You've got the latitudes and longitudes. Again, you can make measurements with this, and you know where your resources are to deploy that are deployed during the recovery. All right. So with that, I'd like to thank everyone for joining us today. We appreciate your attention and time. We welcome any questions that you may have. We'll we'll put out an answers list of the questions that were asked through chat, and further information, either contact us directly at contact@americanaerospace.com, or there's more information on the website. We look forward to any additional questions and interests you may have. Thanks very much.